in how to use a least common multiple. So, as we take a peek at this first sheet, what we want to do is we have to have a feel of how to count, kind of do with counting numbers and multiples. That's good. So, for instance, if we're trying to find the least common multiple of 3 and 4, basically what we do on these is we start listing off numbers. So if we start counting by 3s, we've got like 3, 6, 9, 12, 15. And we may not necessarily have to go as far as the sheet does every time, but it's good for us to be able to see how this works. So we're just going to kind of count, and then we're going to do the same thing with the other number if we're trying to find the least common multiple. We're going to count by 4s. What our goal is in making these lists is to find the first number that both lists have in common. So what would that be this time? 12. I'm looking through here. So my LCM, I'm not going to worry about the common multiples. My LCM ends up being 12. Now you're like, okay, I can kind of see where this could possibly come in handy somewhere. Maybe not quite yet, but I see how this is going to work. So I want to show you some on here so you can see where a benefit could be of understanding these, but where it can also be a little bit of a pain in the rear. Okay, so here, right, if I started making 2 lists, and I had 2 and I had 7, I need to start writing off multiples until I find one that's the same in both lists. Now, sometimes it may not take me very long. Other times it may take me a little bit. And I'm like, finally, I found one that's the same. These lists can get kind of long. Now, there is a difference between LCM and GCF. Yeah, slight difference, because here we're just looking for multiples. We're not looking for the largest factor that goes into both of them, even though we've done that before on some of these. So what we're going to do is, so if I do it, let's say, with the 4 and the 10, and again, sometimes if I'm counting by 4s, and if the whole multiple thing even sends you for a loop, that's okay. Yep, you can still just kind of go to a calculator and even just keep doing +4, +4, +4 if you want to. So you're like, you know, Harty, this could get to be kind of lengthy sometimes. Yes, it really does need to be the least, because that's going to make it the simplest when we go to do a problem. Now, you'll notice on the first one, 2 times 7 is 14, but you're like, well, that didn't work on this one because 4 times 10 would be 40. I'd still, if I was doing an equation, be able to use the 40, and I think that's how we're going to kind of do this. But let's do these on the front and kind of see how this works. So if I do 4 and 5, again, I just start counting. Now, I just did the 4 list, so this shouldn't take me long. And yep, and we're going to be at 20 again. If I start counting by 5s, the first number in both lists that we have in common is 20. And this helps when we have fractions and equations that aren't quite the same. So it sounds like I have a couple of experts out there in this field. 6 and 10, let's see. I need to do this till I find one that ends in, there it is, ends in 0. Because when you think about it, if you count by 10s, they all end in 0. Okay, so basically the whole idea of this kind of mini lesson before we get into the equation itself. Okay, because remember, yeah, 12 itself would be in its list. So I agree with you, 24 would be in both lists, but 12 is going to be the one that shows up first. So that can, exactly. So sometimes It may just even be the number itself. But yep, Mike was saying, in this case, 18, even though it's the first number in its own list, can also count with these. I am. Okay. So, here's where this can get to be a little bit of a pain, though, if you're not real good with your multiples. I only want to take a look at one of these on the back, just to kind of prove a point. So let's say we get over to the back, and you're not incredibly good with your multiples, and you're looking at the first one. So you're like, okay, well, I can do 25 and just count like I'm counting quarters. So you write a few down. Then you start looking at the threes. So here's my 3, and I start counting by 3. And I'm going along. And I'm like, okay, none of the numbers match yet. I'm going to keep counting by 3. And I keep going, and none of the numbers match yet. And I keep counting by 3. And I don't have a number yet. And I'm starting to get tired of doing this. Oh my freaking gosh. It is. Holy freaking cow. I feel like I'm writing for... Okay. Woohoo! Okay. I don't want you doing that. Okay? I don't want you looking at these going, oh my god, it's going to take forever. I mean, I'm just going to blow this assignment up just because of the time commitment. Okay? Here's what we're going to do. Notice, what's 3 times 25? 75. So when we go to actually start doing these, if you're good with least common multiple and you can snap it off right away, use that. If not, we're going to multiply by 2 numbers together. Let me explain what I mean. Okay? I'm going to switch sheets right now. I'm going to go to the actual homework page. And I'm going to do something else besides that. You'll notice there's not a ton of space here. There's some, but there's not a ton. So what I'll offer up is if you want scratch paper to use for this, you can have it. Okay? But here's how we're going to work this. And you've got room on the back of your paper, so even if you just wanted to put the first step here and then flip it over, that's quite all right. But I'm just going to write it on here so it's a little bit bigger. I want you to be able to see everything that I do. All right, so if this is my first problem, okay, and we're not going to go to decimals on this, here's what I want you to do. Multiply the denominators, multiply the numbers on the bottom together, okay? So in this case, scooch this over a little. Okay, so 7 times 2 is 14, okay? If there's 3 numbers in the denominator, multiply all of them together. You might get some big numbers, but we have a calculator, so it's okay. Here's how this is going to work. I'm going to multiply everything in this equation by 14. So I'm going to do it here. Because I'm just going to keep life simple by multiplying the denominators together. Because what you're going to notice is, I'm going to get rid of all the fractions this way. This is going to be kind of cool. So here's how it works. 14 times 4, 56. You can double check me on the calculator if you're not sure. What's 56 divided by 7? Calculate it if you have to. 8. Okay? So that funky fraction just became a whole number. Okay? So we multiply by the number on top and then divide by whatever's down below. And then we just do that. Because 14 times 1 is 14, divided by 2 is 7. And even if the number wasn't a fraction to begin with, you still do it. 14 times 5 is 70. There's nothing to divide by. Our whole goal, okay, is to get rid of the fraction part. Because this, we've been doing forever. This we can do. This, maybe not so much. So now, what do I do to work on getting x by it? Okay, plus the 7. And again, if we've got to do some of this on the back, that's okay. Okay? If you get a decimal, here's what I want you to do. If you get a decimal, I want you to just leave the fraction alone. So I just leave it 77 over 8, 77 divided by 8. Because if we start the problem with fractions, if it ends up that way, it's okay. We'll just leave it as a fraction. Oh, absolutely, because I was going to do number 2 as well. I was going to do a few here. I want to make sure we kind of get the gist of this idea. Because I want to do some of the ones that are a little bit bigger down below, too. How did I get what? Whoops, hang on. Let me slide this over. I lost my first part. The 7, I'm just multiplying the denominators together. And then that's the number I'm going to multiply through by. Okay? So like on number 2, for instance, I'm going to multiply the numbers in the bottom, in the denominator of my fractions together. So 3 times 2 in this case is 6. And that 6 is what I'm going to multiply all the way through by, because that's going to dump all these fractions. So again, 6 times 2 is 12, divided by 3 is 4x. Don't lose your variable there. 6 times negative 3 is negative 18. And then just keep right on going. 6 times 1 is 6. Divided by 2 is 3x. And finally, 6 times negative 1 is negative 6. Again, similar to what we've been doing now. Except, I have x's on both sides of the equation. How do I get them all to one side? Okay, now, this is equals. Okay? So here, yeah, we're going to have to subtract. If they're on the same side, we can just combine like terms. And I heard some of you say it, and that's a good idea. Oh, okay. So instead, right. Okay, so we could minus 3x, or you could do the 4x as well. And again, don't lose the sign on your 6. That's still a minus or a negative. What's my one last step then to get x alone? I want this by itself. How do I add the 18? And again, watch your signs. I'm $6 in debt, but now I found $18 in my pocket. I'm $12 ahead. So it's a process with these. It really is. But we're just going to keep life simple and multiply the denominators together. Now, let me find a doozy here, because some of these get a little bit ridiculous with the numbers. That's why you have a calculator. Yeah, you can either write them there, but again, just make sure as we're doing these that you're kind of working through these with me to make sure we're on the right track here. So let's see. Where's one that looks ridiculous? Okay, let's say, which one? 19. I even want to get more ridiculous. Let's get crazy ridiculous. Like, number 9 is going to be ridiculous numbers. Let's look at 9 for a minute. So if we're checking out 9, holy cow, we got 3 numbers to multiply together now. So this could get kind of big and ridiculous. Now see, if I was comfortable with my, I was going to say, if I'm comfortable with the least common multiple, 15 is going to be it. But if that whole idea kind of, what I would do here is I would multiply those 3 numbers together. Now this might get kind of big. 225, holy cow. Here's where we got to go to the calculator. I'm still going to do the same thing. 225 times 4 is 900. Divided by 5 is 180. Ooh, still comes out clean, it's just a big number. 225 times 1 is 225. Divided by 3 is 75. Oh boy, now I'm going to start prepping my own math. 225 times 7 is 1575 divided by 15. I could do this with 105. You're like, dang, Harty, those numbers kind of big. They are, but again, if we know our steps, this isn't really a big deal. I want to get 180x alone. How do I get the minus 75 out of there? Plus the 75. And then just divide by the 180. And it equals 1. So don't let the big numbers mess with you. We still can get this done. Nothing too terribly awful. All right, let's find one more here to play with. Which one up in the top part, okay, where it's actual equations? What? In just a moment, yes. Yes, yes. Pick out one more that we want to take a peek at. 3, okay. And I'll just give you a heads up, 21 through 24 you can skip for now. I am very content with you just dealing with doing this stuff. Yes. All right, 3. Somebody tell me, using the method we're talking about using right now, times 2. 10 times 5 times 2 is 100. So we're going to multiply through by 100. You're like, all right. So 100 times 3 is 300. Divided by 2 is 30. And again, using the calculator is no big thing on this. That's fine. So 200 divided by 5 is 40. Multiply by the top, divide by the bottom. 100 divided by 2 is 50. 6 times 100, I agree, is 600. Don't forget the minus, though. Okay, right. Here, I have x's on both sides of my equals. So I have to do an opposite to get them together. So minus in the 30 would work. If some of you chose to minus the 50, that would work okay, too. Right, so I'm trying to get the x's alone, so I need to get whatever's with that out of there. And then we just divide. So we're not changing up with anything, not doing anything crazy. We're just working at getting through to the end. So your task is to try and knock out the rest of them up at the top. Again, 21 through 24 we are not worrying about. And if you need some extra scratch paper, I've got that up there or writing on the back. But again, I got to see where some of this is coming from. At least a step here and there. And like I said, tomorrow we'll be doing a review that goes over all the different types of equation stuff we've been doing to end the last week and just now. And then Wednesday we'll do a mini quiz on getting that set. And we'll get into percentages, some actual life applications, and a couple of interesting stories on percentages in sales at stores. So give that a go. And